If you drive a modern performance car, BMW M3, a Mustang GT, or even a Porsche 911, you are used to a very specific sound ceiling. You hit the gas, the needle climbs. And then, at around 7,000 RPM, you hit a wall. The rev limiter cuts you off. The party is over. To a car driver, 7,000 RPM feels like screaming. It feels like the engine is about to explode. But in the world of high-performance motorcycles, 7,000 RPM isn't the red line. It isn't even the power band. It is idle. On a 600cc supersport bike, when your Porsche is begging for a gear change, the bike is just clearing its throat. These machines don't stop at 7,000. They climb to 14, 15, sometimes 16,000 revolutions per minute. That is 266 revolutions per second. This isn't just a difference in sound. It is a difference in physics. It is the difference between an engine designed to last 200,000 miles and an engine designed to win a race, even if it destroys itself. Today, we are going to look at the engineering that allows a street-legal motorcycle to spin faster than a Formula One car. To understand why your car engine is so lazy compared to a bike, we have to look at the single most important number in engine building. It is not horsepower. It is not torque. It is mean piston speed. Imagine the piston inside your engine. It travels up to the top, stops dead, and then travels down to the bottom. It does this thousands of times a minute. The limit of an engine isn't how fast it can spin. It's how fast the piston can travel before the G-forces literally rip the metal apart. In a long-stroke car engine like a V8 or a four-cylinder turbo, the piston has to travel a long distance. It's like a sprinter running a 100-meter dash. It takes time to get there and back. If you spin that car engine to 10,000 RPM, the piston speed would be so high that the connecting rods would stretch, the valves would float, and the engine would turn into a grenade. So, how does the bike cheat this limit? It changes the geometry. Motorcycle engineers use a concept called Oversquare Geometry. Instead of a long, narrow cylinder like a car, they use a wide, flat cylinder. The piston is huge, but the distance it travels, the stroke, is tiny. It's not running a 100-meter dash. It's running a 10-meter shuttle run. Because the distance is so short, the engine can complete the cycle twice as fast without the piston actually moving any faster effectively. This is why a Yamaha R6 sounds like it's screaming. The pistons aren't necessarily moving faster than a Ferrari's pistons. They are just completing the lap in half the time. This is the secret. It's not magic. It's multiplication. Now, you might be thinking, okay, so they make the stroke short. Why don't they do that in cars? They do, but only in one type of car. Formula One. A Formula One engine is the closest relative to a sport bike engine. It uses pneumatic valves. It uses exotic materials like titanium and Inconel. And it uses that same Oversquare geometry to hit crazy RPMs. When you buy a sport bike for 10 grand, you are effectively buying a slice of F1 technology that has been detuned just enough to run on pump gas. You are getting titanium valves. You are getting forged pistons. You are getting an engine that breathes more air per liter than almost any supercar on the planet. A Ferrari 458 Italia, one of the greatest engines ever made, produces about 125 horsepower per liter. A BMW S100RR, it produces over 200 horsepower per liter. That is not just efficient. That is engineering arrogance. The final argument I hear from car enthusiasts is about reliability. Oh, an engine spinning that fast must blow up every week. And this is where the bike pulls its final trick. Because the motorcycle is so light, the engine is rarely under full load. A car engine is constantly fighting 3,000 pounds of weight. It is always stressed. A bike engine is pushing 400 pounds. Even though it spins at 14,000 RPM, it is barely breaking a sweat to maintain highway speeds. I have seen Honda CBRs with 100,000 miles on the odometer engines that have spent half their lives at redline still running like Swiss watches. Why? Because precision is the ultimate durability. When you build an engine to handle 16,000 RPM, 70 miles per hour is a vacation. So, the next time you are in your car and you hear a bike fly past you, screaming like a fighter jet, don't just think it's loud. Respect the math. You are listening to an engine that is defying the friction limits of conventional mechanics. You are listening to a piston that is changing direction 260 times every single second without failing. You are listening to the sound of compromise leaving the building. If you think your car sounds better, let me know in the comments. But I think we both know the truth. I'll see you in the next one.